Okay, so we're doing systems of equations graphing discovery. Systems of equations, two or more equations with two or more variables, so an x and a y. Okay, answers will always be in the form of an ordered pair of x, y. It's always in an ordered pair. You don't have just one number. One way to solve the system of equations is by graphing the two equations. Three things could happen. They could cross, they could never cross, or they're the exact line, intersect at all points. So if I look at this first one, I'm going to graph the first equation. I'm going to graph this one. Okay, my y-intercept is 0, -5. My slope is 2 over 1. So I'm going to go 0, -5, and 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I'm going to draw a line, making sure that I put arrows on it. And I'm going to change colors. Obvious. Oops, not to that one. I'll change it to this. So my y-intercept here is 0, 2. And my slope is -1/3. So that's going to go downhill. Okay. Okay, so here we go, 0, 2. I'm going to go down 1 over 3. Or I could go up 1 over 1, 2, 3 to the left. So if I have this, now the solution is where they run into each other. So the point where they run into each other is right there. So the solution to this is going to be the point 3, 1. The slopes are different. The y-intercept can be same or different. How many solutions are there? There's one solution when the lines cross or intersect. Okay, let's go to the next one. Let's look at this. I'm going to use, red. So my slope here is 3. My y-intercept is 0, -1. So up 3, 1, 2, 3 to the right 1. Up 3, 1, 2, 3 to the right 1. Or I could have gone down 3 to the left 1. Doesn't matter either way. And that's pretty good. Then on this second one, I'll use light blue. My slope here is 3, or 3 over 1. And it goes through the point 0, 2. So I'm going to go to 0, 2. I'm going to go up 3, 1, 2, 3 over 1. Or I could have gone down 3, 1, 2, 3 over 1. Down 3 over 1. And when I draw the line, that was a horrible line, but I can make it. Okay, if you notice, the solution, they don't run into each other. So there's no solution on this. Solution. There's no solution. The slopes, if you look at the slopes, they're exactly the same. And the y-intercepts are different. Okay, let's go to this next one. This next one, if I graph this, I have a slope of 2 and a y-intercept of -2, not -1. So I go down to 0, -2. I go to up 2 over 1, up 2 over 1, up 2 over 1, or I could have gone the other direction, down 2 and over 1. Ding. There we go. And I draw that. If you notice, I'm going to use, actually, let's do green. There we go. Look at this. Slope is 2. Y-intercept is -2. So I go here, and I'm going to have the exact same line. Look at that. It's the exact same line. So this is infinite solutions because they have all the same solutions. The slopes are the same and the y-intercepts are the same. There are infinite solutions when the lines are the same. Did I fill in this thing up here? No, I forgot to fill in this one. There's no solution when the lines are parallel. Oh, I just spelled parallel wrong. Sorry about that, guys. Here, if you were given the equation right there, write another equation that would provide you with each of the following. So, y equals blank, blank. This right here cannot be 3. This can be anything. Okay, so if I have this one, this has to be the same. The slope has to be the same. This has to be different. And last but not least, if we have infinite, same, same. Now, if you were given the following graphs, how many solutions would each system have? Well, the first set, they're parallel, so there's no solution. This next one, it has one solution, but you can't just write one solution. You have to actually say what that one solution is, and that looks like -1, -2. This one, because there's one line, that means it's probably one over the other one. So this is infinite solutions. And then again, this is one solution, but we don't write just one solution. We actually write what that solution is, and it looks like the point 4, -1. Okay, if you were given the following set of equations, how could you tell the ordered pair was a solution without graphing? Well, what's the y-intercept for the first one? 0, 3. What's the y-intercept for the second one? 0, 3.